Welcome back. This video is about EC2 storage options. When it comes to selecting storage options for Amazon EC2, you have multiple storage options. You can choose the one that best fits your requirements. For example, you can use EBS volumes, instant storage volumes, EFS, S3, and many other related storage services. In this video, we will talk about EBS volume, which is a durable storage option. The other one we will talk about is instant store volume, which is transient storage. You can use Amazon EBS as a primary storage device if your use case requires frequent and granular updates. For example, Amazon EBS is the recommended storage option for running databases on Amazon EC2. Amazon EBS provides 3 volume types to best meet your needs for various types of workloads: solid-state drive or SSD volumes, hard disk drive or HDD volumes, and previous generation volumes, also called magnetic. Let's talk about solid-state drive, SSD volumes. SSD-backed EBS volumes are optimized for transactional workloads that have frequent read or write operations with small I/O sizes. SSD-backed volumes are a good choice when the dominant performance attribute is IOPS. The reason is that the important performance attribute for SSD volumes is IOPS, which means SSD volumes provide higher IOPS compared to HDD volumes. There are 2 types of SSD-backed EBS volume: general-purpose SSD and provisioned IOPS SSD. Let's talk about general-purpose SSD. General-purpose SSD is the SSD-backed general-purpose EBS volume type. It is recommended default choice for AWS customers. They are suitable for many workloads, including small to medium-sized databases, development and test environments, and boot volumes. Next, let's talk about provisioned IOPS SSD. Provisioned IOPS SSD volumes offer storage with consistent and low latency performance. They are designed for I/O-intensive applications, such as large relational or NoSQL databases. Let's look into a summary of the use cases and characteristics of SSD-backed volumes for both general-purpose SSD and provisioned IOPS SSD. This screenshot and discussion should provide a good general understanding as it relates to in which use case one type of SSD is better than the other. As you can notice from the screenshot, GP2 and GP3 are general-purpose SSD volumes, and IO1 and IO2 are provisioned IOPS SSD volumes. Provisioned IOPS SSD volumes have much better durability. Use cases-wise, general-purpose SSDs are good for transactional workloads, medium-sized single-instance databases, low-latency interactive applications, boot volumes, development, and test environments. On the other hand, provisioned IOPS SSD volumes are good for workloads that require sub-millisecond latency, sustained IOPS performance, IOPS throughput in the high range, and I/O-intensive database workloads. Let's talk about volume size. General-purpose SSDs provide volume size in the range of 1 to 16 terabyte, while provisioned IOPS SSD volume provides a much larger size, up to 64 terabytes, and the min size is 4 gig. Here, if you notice, it is mentioned in tebibyte, which is more accurate as it uses the binary prefix means 2 as a base power. When saying terabyte, which is the decimal prefix, means it uses 10 as the base power. Though in informal communications, you may hear the term terabyte, megabyte, or gigabyte, and similar more commonly. I will also use the common terms means terabyte, megabyte, or gigabyte, and similar just to make it easier. Let's talk about max IOPS. General-purpose SSD provides up to 16 kilobytes, while provisioned IOPS SSD provides much greater IOPS, as you can notice, up to 256 kilobytes. Provisioned IOPS SSD has better throughput than general-purpose SSDs, and EBS multi-attach is not supported in general-purpose SSDs, while provisioned IOPS supports multi-attach EBS. Both of them can be used as boot volumes. I think with this screenshot and discussion you got a sound technical judgment of when to use general-purpose SSD and when to use provisioned IOPS SSD. Now let's talk about hard disk drive, HDD volumes. HDD-backed volumes are optimized for large streaming workloads. HDD volumes are a good choice when the dominant performance attribute is throughput. In other words, if your non-functional requirement of deciding volume type is throughput, not the IOPS, as in the case of SSD-backed volumes. There are 2 types of HDD volume types: throughput optimized HDD and cold HDD. Now let's understand cold HDD and throughput optimized HDD volumes with the help of this screenshot. The first thing to notice is that there is no support for boot volumes. This means HDD volumes cannot be used as boot volumes, and multi-attach EBS is not supported as well. Cold HDD volumes define performance in terms of throughput rather than IOPS. Cold HDD provides low-cost magnetic storage compared with throughput-optimized HDD. Because of low-cost magnetic storage and a lower throughput limit than throughput-optimized HDD volumes, cold HDD volumes are a good fit for throughput-oriented storage that is not frequently accessed, and the lowest storage cost is critical. On the other hand, throughput-optimized HDDs are a good fit for big data, data warehouses, and log processing. Volume size is in the range of 125 GB to 16 terabytes. And max IOPS, as you can see, max IOPS for HDD is way less than what is provided by SSD volumes. And max throughput, as you can see, max is about 500 MB per second, which is for throughput-optimized HDD, which is less than what was throughput provided by SSD volumes. Though both HDD and SDD provide ample storage capacity and SDD volumes provide better performance than HDD volumes in most aspects. However, SDDs are relatively more expensive than HDDs. Let's quickly understand magnetic volumes in brief. Magnetic volumes are previous generation volumes that are backed by magnetic drives. Magnetic volumes provide the lowest cost per gigabyte of all EBS volume types. They are ideal for workloads and applications where data is not accessed frequently and where the lowest storage cost is important. Magnetic volumes deliver approximately 100 IOPS on average, and they can range in size from 1 GB to 1 terabyte. Another important storage type is instant storage. Many Amazon EC2 instances can also include storage located inside the host computer, referred to as instant storage. It is also called ephemeral storage because of its transient nature. Instant storage provides temporary block-level storage for Amazon EC2 instances. This means the data on instant storage persists only during the life of the associated instance.